Hello ladies and gents, this is Daniel for Rock the JVM, and in this video I'm going to show you testing styles in ScalaTest. Now, this video that I'm going to show you here with ScalaTest works with both Scala 2 and Scala 3 regardless of which Scala version you use. And by the way, Scala 3 has just been launched and I'm really excited about it, and you're going to see massive updates to the Rock the JVM courses on Scala Beginners and Scala Advanced for Scala 3, so expect those shortly. And this particular video on ScalaTest assumes that you're just getting started with Scala testing in general. So I recommend that you code with me, and whenever you need to refresh your memory about the concepts or the testing styles I'm going to show you, just refer back to this video or to the written form at the blog with the link in the description as always. Alright, so that being said, I'm gonna head back to my development environment, and I'm using Scala 2 for this video because IntelliJ is still pretty poor on Scala 3, but it's going to get up to speed quite shortly. And I have here a small class that I called Scala Testing Styles, and I placed this Scala Testing Styles class under source test Scala, so not under source main Scala, but under source test Scala in my IntelliJ SBT project. And speaking of SBT, you will need to add the Scala test libraries in your build.sbt file. So under library dependencies, you're going to have to add ScalaTest %%ScalaTest, and I'm using the version 3.2.0 or 3.2.7 at the moment of this recording. And you'll need to add these two lines to your build.sbt file. You'll find those in the article in the blog version of this video. So getting back to the video, I'm going to head back to my Scala testing styles file, and I'm going to show you various testing styles that you can use with ScalaTest. And for this video, I'm going to test a very simple class that I'm going to call calculator. So I'm going to define a small class called calculator, and I'm going to add a bunch of methods to this calculator class just to add, subtract, multiply, and divide two numbers. So I'm going to define a method called add a int and b int, and this returns an int, and this is a plus b. All right, so pretty simple operations, and I'm going to add a bunch of other methods. So I'm going to have a subtract, and this is a minus b. I'm going to add a multiplication method, and I'm going to add a division method, and I'm going to give them the proper names. So multiply and divide. So I'm going to create our first testing suite for this calculator. So I'm going to define a small class. I'm actually not going to define it in the Scala testing styles class. In fact, I'm going to make this an object and I'm going to leave it empty. I don't really care about this one. I'm going to create a class and I'm going to call this calculator suite. And this extends from ScalaTest. I'm going to use any fun suite. So any fun suite is a testing style in ScalaTest, and this is expressed as a class. And this exposes a bunch of methods that you can define tests for. So in this calculator suite, I'm going to reuse a calculator instance because this calculator is really stateless. So I'm going to define a val calculator as new calculator, and I'm going to test this calculator. And the way that you test things with any fun suite, so with test suites, is to describe independent tests. So you describe independent tests as test. So you use this method and you give this test a name and a descriptive name. So for example, multiplication by 0 should always be 0. And after the description, you need to add the body of the test. And in this test, I'm going to use plain old assertions, which will throw errors in case the assertions inside turn false. So I'm going to add assert, and the condition is a boolean here. So I'm going to assert calculator dot multiply, and I'm going to add a random number, and I'm going to multiply that with 0, and I'm going to force that to be a 0. So in case this condition returns false, the assertion will throw an error and the test will fail. And I'm going to use a bunch of assertions, and I'm going to multiply a negative number with 0, and I'm going to multiply 0 with 0 just in case. And just for the sake of variety, I'm going to add another test. So I'm going to add a test for division. So I'm going to say dividing by 0 should throw some math error. And I'm going to use another assertion tool from ScalaTest. I'm going to use assert throws. And I'm going to assert throws with the type arithmetic exception. And I'm going to use calculator divide. And I'm going to have this same number that I'm going to copy here. And I'm going to divide that by 0. So notice that in a fun suite, you can define independent tests. So this is very similar to the JUnit or MUnit style that you might have seen elsewhere. So you define independent tests, and when you run them, all of them should pass. So I'm going to run calculator suite, and all of these tests will show independently here in my test runner. So multiplication by 0 should always be 0, and so on and so on. So fun suites are the simplest testing style in ScalaTest. You define independent tests. Now I'm going to show you some other testing styles, and with increasing power used from the Scala language. So I'm going to define another class. I'm going to call this calculator spec. So notice I'm naming this spec because I'm going to extend any fun spec instead of any fun suite. And spec comes from specification, so we're going to test specifications, that is behaviors. So we're slowly moving towards behavior-driven development. And when you want to test behaviors, you're going to structure your tests in a different way. So I'm going to show you how those will look like. Again, I'm going to define another calculator as new calculator. And here I'm going to describe tests with a describe method. So any fun spec instead of any fun suite will have some other methods that you can use for defining behaviors that you want to have under tests. So I'm going to have describe, and I'm going to describe multiplication as in the behavior that I want to test. And inside I can add another describe. So I'm going to describe, for example, some other test. So notice that you can now nest tests into one another, and this will create a more structured environment for your tests. Now, individual tests, individual units, are described with a keyword it. And it's not a keyword, but it's a special value here exposed by any fun spec, and it is invocable actually as a method. That is, it has some apply method, and this will have a description. For example, should give back 0 if multiplying by 0. And now I'm going to add the body of this unit. So I'm going to copy these 3 assertions, and I'm going to paste them here. So notice that it should give back 0 if multiplying by 0. This is a unit, and this belongs to the multiplication behavior. And this will show in the appropriate way in the test runner. And I'm going to describe another operation, another behavior, and another specification here. So I'm going to describe, and I'm going to use division. And I'm going to have it should throw a math error if dividing by 0. And I'm going to copy this line, and I'm going to add it here. And now when I run this calculator spec test, notice that I'm hovering over the calculator spec space here. So I'm going to run just this testing suite. And notice that when you run the tests like that, the tests are nested. So whenever you have a test that fails, you already know which behavior you need to look into. So this is quite powerful, and this is moving towards BDD. Now, there is another testing style in ScalaTest that makes a little bit more use of the Scala expressiveness, and I'm going to show you word specs. So I'm going to scroll down, and I'm going to define another class, and I'm going to call this calculator word spec. Word spec because we're still testing specifications, and word because we're using some quote-unquote keywords that make this testing sound like natural language. And this extends any word spec. Now, again, I'm going to create another calculator inside. And instead of describing tests independently with the keyword describe, I'm going to write the following. I'm going to say a calculator like the string, and any word spec contains some extension methods to the string type. And in Scala 2 and Scala 3, they're implemented differently, but you don't really need to care about that. Now, I'm going to use a calculator and then a space, and I'm going to use the should method, and I'm going to use it infix just like that. So a calculator should, and then you describe some other tests inside. And I'm going to use another test description, give back 0 if multiplying by 0, in. And the keyword in, or the in method, is a signal to ScalaTest that a unit test follows. So an independent test will follow inside. And I'm going to paste the same 3 lines here because the test itself doesn't really matter all that much, but the testing structure does. So notice that the test structure sounds a little bit more like natural language. So calculator should give back 0 if multiplying by 0 in whatever scenario you want to test. And again, if you want to test division, I'm going to have throw a math error if dividing by 0 in. And I'm going to have the exact same scenario as we had earlier. So notice that we have a calculator should, and then we have a bunch of things that a calculator should do if you run this these various scenarios. And now I'm going to run the calculator word spec inside here, and the tests will be structured in a very similar way as we saw earlier. So we have a calculator, and we have give back 0 if multiplying by 0, and throw a math error if dividing by 0. These are nested under the calculator. So if you have a large code base and you have a bunch of test suites, you can nest these inside. This is really powerful, and this makes code a little bit more pleasing to read and also to write. Now, the next thing that I'm going to show you is a free spec, because the word spec here, even though it sounds like natural language, it imposes a certain structure in how you design your tests. And this type of structure is usually very good in aligning all the members of your team with the same testing methodology. So this is extremely powerful and also very good in streamlining the same testing convention. Now, what follows is another kind of spec that allows more freedom in how you structure your own tests. And I'm going to define a class. I'm actually going to copy most of this, but I'm going to define a calculator free spec, and this extends any free spec. Now, a free spec has a very similar structure to the keywords should, within, and so on, but the should keyword is absent, and instead you have a dash, which means that you structure your tests in any way that you see fit. So I'm going to copy most of this, including the calculator definition, and instead of the should method, which notice that it's not available anymore under any free spec, it's available under any word spec. The any free spec has another extension method on the string class, which is the dash operator. And the dash means basically anything you want. And this gives you lots of power in how you structure your tests. This is why we have these many testing styles. This free spec is by far the most flexible testing style that you can have in ScalaTest, because you can structure the test in any way you like. And this dash means anything you want. You may have a calculator, and then you can describe a scenario instead of an expectation, like give back 0 if multiplying by 0. Then you might want to set up some things for your calculator if your calculator is stateful or not. So this dash can do lots and lots of things. So the free spec is the most flexible kind of testing style that you can use for your classes. Now I'm going to show you some other tools here with ScalaTest, and namely property style checking or testing. Now, this is not the same as property-based testing with another kind of library for testing, which is called Scala check. So do not confuse ScalaTest with Scala check, especially when you're starting out. The property style checking allows us to specify the examples that we want to run through, whereas Scala check the library for property-based testing generates the testing examples automatically. So I'm going to define a class called calculator prop spec extends any prop spec. Again, we're testing specifications here, so we're in the behavior land, and I'm going to define another calculator as new calculator. And here I'm going to define some testing examples. For example, notice that we have a bunch of lines here if we have calculator multiply. Now, 3 examples is fine, but if you have a number of examples that are generated programmatically, like thousands of tests or thousands of examples, the test written manually might not be really wieldy. So I'm going to define a testing sample here. So I'm going to define a val called multiply by 0 examples. And I'm going to have a list of tuples here, and I'm going to use this tuple 653 whatever, and then the negative 653 whatever, and then the tuple 0 and 0. All right, so I'm going to use these examples, and imagine that these examples are generated by you. So you're generating like 1,000 examples, and pasting them would make your test really ugly, not to say slow. So I'm going to define what is called a property. So I'm going to have property. Notice that we have the property method available from any prop spec, and I'm going to add a test here. For example, calculator multiply by 0 should be 0. So I'm going to have the whole description of a property, and here you have the body of the test, and you can use some other tools in ScalaTest, which is table checking, but I'm going to use this simple list. I'm going to use a simple assertions. So I'm going to assert that multiply by 0 examples for all, and I'm going to deconstruct all the examples here. So I'm going to have a case A and B, and I'm going to expect that A times B, actually calculator dot multiply with A and B should always be 0. So I want that for all the examples that I generate over here, the multiplication between these two should be 0. And in case any one of those does not equal to 0, then this whole assertion will fail and the whole property will fail. And this is where you will see red in your testing runner. So I'm going to define another property, and I'm going to use calculator divide by 0 should throw some math error. And I'm going to have the same assert throws here because I don't have any more examples. But this idea that I showed you earlier still applies for this property too. And if I run this test, you will see these properties as independent tests. So we have calculator multiply by 0 should be 0, and calculator divide by 0 should throw some math error, both pass. Right. And the final thing that I want to show you in Scala check, it's pretty wonky, but it's allowed by the Scala language. And this is something that I show the students of the Rock the JVM course when I want to sell them to the Scala expressiveness. I'm going to define a class called calculator. I'm going to use ref spec. Now, note that we're still in the specification land, so we're in the behavior testing. And this will extend ref spec. Ref spec is a particular kind of testing style, and I'm going to import that. And here under ref spec, this is based on reflection to generate some test cases, and the test cases are structured in the form of Scala objects and methods which have multiple words in their names. Now, if you want to create a variable or an object or a method with multiple words in your name, you would define an object which is called backtick, a calculator. So notice that if you use backticks, then all the spaces are part of the name of this identifier over here. So a space calculator is the name of this object. Then I'm going to open and close some curly braces, or open an indentation style if you're using Scala 3, and inside this is a test suite. And I'm going to define a calculator So I'm going to use new calculator, and I'm going to define another method with multiple words. And to prove that, I'm going to simply copy this method name, this string over here, and I'm going to open some backticks, and I'm going to paste this inside. So calculator multiplied by 0 should be 0. I'm going to remove calculator because I don't really care about multiply the calculator name. So calculator multiplied by 0 should be 0, and I'm going to define that as unit. So I'm going to write colon unit, and I'm going to run some assertions. So I'm going to copy these same 3 assertions, and I'm going to paste them inside. Now, when you write something like this, the ref spec, based on reflection, will investigate all the components of its body. So this will create a test suite, which is called a calculator, and the members of this object, like these defs, are independent tests. So multiply by 0 should be 0 will be turned into a new unit test. And I'm going to define def, and I'm going to use should throw a math error when dividing by 0. And this is again a unit, and I'm going to run that assert throws. I'm going to copy this, paste it here, and now we should be able to run this calculator ref spec. And notice that we have the same kind of testing structure under a calculator. And this is really powerful, but this is based on reflection, so if you have lots and lots of tests, this might run a little slowly depending on how you laid out your tests. But I wanted to show you this wonky testing style here, which is available under ScalaTest. So I hope you liked this introduction and this overview into testing styles with Scala and ScalaTest. I hope you liked this video. If you did, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Check me out on Twitter and LinkedIn. I post fresh updates, including on upcoming material, and I'm about to release a new Cats Effect 3 course and updates to my popular Scala courses updated for Scala 3, so watch those out on Twitter and LinkedIn. And check out the Rock the JVM website. I have tons of content on Scala and Akka and Apache Spark and functional programming and so much more. Until next time, I'm Daniel, signing off.